Okay, those shouldn't have been too bad either. Once you get the hang of looking what's happening, are the things falling apart? Are they coming together? Is oxygen being added on? Is one partner kicking another one out, or are they both exchanging? That's what you're going to want to do. You're going to do another exercise after this now to look and see from the names if you can go through the whole process where you balance each compound individually, okay? Assign charges from the columns in the table, change the subscripts, the little numbers underneath, so that each compound becomes balanced like we did last unit. Then don't forget the diatomics, anything like H, N, O, F, Cl, Br, 2, all those have to have subscripts of 2's. Once that's done, every individual compound's balanced, then balance the left side and the right side. Start with elements that occur the least number of times, count the polyatomic ions as a whole group, and then finish off by making sure that the diatomic gases have doubles in there. So let's go in and take a look at this example. Okay. Let's do this one because I like the acetylene one. We're going to do number 3 here together. Acetylene is given already. Here's the formula for it. There's 2 or 3 places where I give you the formula for it. But that's going to be C2H2 plus oxygen. Yields is given the symbol, arrow. But a lot of times it's given other words like reacts with or forms or changes this substance into. So you look for words that are sort of action words in chemical terms. This becomes carbon dioxide. That's a covalent naming structure. Remember, it's the same as monocarbon dioxide. Here's where those naming come in. Monocarbon. Oops, it's already written. So mono's never starting in the words, and then dioxide, and then you get water over here, which is just H2O. Okay, those things I think you should be able to remember. Now we're going to look at each one individually. This has already been given to us, so we don't have to balance that. Oxygen. Oh yeah, that's one of the diatomics. It's NOF. Okay, it's over in the Magnificent 7. You're going to have to get used to that. Hopefully you've got your periodic table kind of printed off and it's next to you doing these problems. Carbon dioxide's balanced because it comes from its name. And water's balanced because that's a +1 and a -2. So we know that's balanced. Awesome. So each one is individually balanced. Now you got to do left side and right side. I've got 2 C's. Notice I've got, I don't have anything. Well, oxygen's in between things. So let's leave oxygen for last, okay? So 2 carbons. I'm going to need 2 carbons here. I have 2 hydrogens, which I already have 2 hydrogens there, so that's nice. And I can now then do my little oxygen trick. Here's one way I can do this is cover up by diatomic. Say, how many oxygens on that side? Well, I've got 4 plus 1 more is 5. Here's where that trick helps me not to brain twist so much. I said, I'm going to take 5 halves of an oxygen. That means I can get them out by one. That's why I can do this trick. But I don't like halves because my recipe is not good with that. I can only do these in whole numbers. So I'm going to double everything and get rid of that half. So I'm going to double this. It just takes the half out. Okay, so I got 5 oxygens. I'm going to double this one, which is going to become 4. And this is going to become 2. If I look up, all my atoms are going to balance out. So that's one way to remember those. I think there's any other tricky ones. I think that should be good. Give those another try. I'll put some answers up for you as well.